everyone, and welcome back to the channel. Before we begin, make sure to subscribe and follow the channel if you love mega engineering, impossible construction projects.
And the hidden systems that keep entire nations alive. Today, we are going deep into one of the most incredible.
This is the story of how Saudi Arabia pumps billions of liters of water across one of the driest desert nations in the world.
But here is the part most people get wrong. Saudi Arabia is not simply pumping seawater straight into the desert. That would be impossible.
Seawater cannot be sent directly to cities. It is too salty, too corrosive, and completely unusable for drinking, farming, or industry.
So before a single drop can travel inland, it must pass through one of the most complex engineering chains ever built.
Seawater intake structures, massive desalination plants, power stations, storage tanks, high-pressure pumping stations,
and giant buried pipelines stretching across the desert. The journey begins on the coast, at Ras Al Khair near the Arabian Gulf.
Engineers first build a seawater intake system.
Before construction even starts, survey boats scan the seabed.
Engineers mark the shoreline, and drilling rigs test the ground beneath the future plant.
Then marine crews dredge a straight intake channel through shallow coastal waters.
This channel becomes the first gateway of the entire system. To protect it from waves and shifting sediments, massive breakwaters are built layer by layer. Smaller core rocks go in first, then giant armor stones are placed on the outside. Behind this protected marine zone, workers excavate a huge concrete intake basin. Reinforced steel is tied, concrete is poured, walls rise, and precise slots are built for screens and gates.
This is where the ocean begins its transformation.
Inside the intake basin, trash racks and traveling screens are installed to block debris before seawater reaches the pumps.
Then the seawater intake pump house is built directly beside the basin. Huge pumps, motors, discharge pipes, and valves are installed, all aligned with incredible precision.
From here, seawater is pushed into the first treatment stage. But it still cannot be desalinated yet.
First, it must be cleaned. Engineers construct long, rectangular pre-treatment basins. These basins remove suspended solids, control particles, and prepare the seawater for the more advanced systems ahead. The chemical dosing tanks are installed. Coagulants, chlorine, antiscalants, and pH control systems are added. Then the water moves into dual media filters, where layers of gravel, sand, and anthracite remove even finer particles.
Only after this does the water enter the heart of the plant, desalination. Saudi Arabia uses massive desalination technologies,
including reverse osmosis and thermal multi-stage flash systems. In the reverse osmosis hall, workers build a long industrial structure filled with rows of pressure vessels. Membrane elements are carefully loaded into these vessels. High-pressure pumps are installed to force filtered seawater through the membranes, separating fresh water from salt.
Energy recovery devices are added to reduce the enormous power demand. But the system does not stop there.
Nearby, engineers construct the multi-stage flash desalination block. This is a much heavier thermal system.
Massive concrete foundations are poured. Giant evaporator modules are transported into place.
Using heavy haul vehicles and cranes. Tube bundles, brine heaters, steam pipes.
Condensate pipes, insulation, and maintenance platforms are installed. This part of the plant uses heat to flash seawater into vapor, then condense it back into fresh water.
And because desalination requires an enormous amount of energy, a power plant must be built beside it.
Gas turbine foundations are excavated and reinforced. Massive concrete blocks are poured to support rotating equipment. Steel frames rise to form the turbine hull. Gas turbines, generators, air intake systems, fuel systems, lubrication systems,
HVAC units, exhaust ducts, Chimneys, transformers, and switch yards are installed.
This power block gives the desalination plant the energy and heat it needs to operate at a national scale.
But even after the seawater becomes fresh water, the job is not finished. Desalinated water is too pure and must be stabilized before it can travel across the country. So it passes through remineralization and chlorination systems. Minerals are added back, disinfection is applied, water quality is monitored. Then the fresh water enters huge circular storage tanks. These tanks are built one stage at a time. Circular foundations, steel floor plates, shell plates, upper courses, pale roofs, access stairs, overflow pipes, level sensors, and giant inlet and outlet manifolds. From above, the tank farm looks like a clean geometric grid in the desert. Next comes the real challenge, moving this water inland. A main transmission pump station is built downstream of the storage tanks. Massive pump foundations are poured. A large pump hall rises. Huge transmission pumps and motors are installed. Surge protection vessels are added to protect the pipeline from dangerous pressure waves. Outdoor manifolds, valves, flow meters, and discharge headers connect the pump station to the pipeline corridor.
And then the desert pipeline begins. Giant coated steel pipes, some around 72 inches in diameter, are delivered into the desert.
They are laid out in long rows beside the trench. Excavators dig the pipeline trench. Bedding sand is placed. Side boom tractors align the pipe sections. Welders join the pipes together. Every weld is inspected using non-destructive testing. Every joint is coated for corrosion protection. Then, in one of the most dramatic construction moments, multiple side boom tractors lift the long welded pipe string and lower it carefully into the trench. The pipe is padded with sand, covered with warning tape, buried, and marked above ground. Along the route, engineers build valve stations, air release chambers, washout chambers, cathodic protection systems, and telemetry sites.
This is not an open canal. This is a sealed, high-pressure freshwater artery buried under the desert. Because the distance is so huge, intermediate pump stations are built along the route. These stations boost the water pressure,
control surge forces, and keep the flow moving across hundreds of kilometers of desert terrain. Finally, the water reaches the terminal reservoir site near Riyadh. There is no sea here, no coastline, only desert and the receiving end of a national water lifeline. Crews build more circular storage tanks,
inlet manifolds, distribution pump stations, rechlorination systems, SCADA control buildings, and telemetry towers.
Sensors track pressure, flow, tank levels, chlorine, conductivity, and system alarms. Before full operation, the entire system must be tested. Pipelines are pressure tested.
tanks are flushed, chambers are inspected, the system is disinfected, water samples are taken. SCADA signals are checked from the coastal plant to the desert pipeline and all the way to the terminal reservoirs. Then comes the first synchronized transfer. At the coast, seawater enters the intake channel. It passes through screens, pretreatment filters, RO membranes, and MSF thermal systems.
It becomes fresh water. It is remineralized, disinfected, stored in giant tanks, and pushed by massive pumps into buried desert pipelines. Intermediate stations boost it forward.
And finally, the water arrives near Riyadh. This is the hidden engineering miracle behind modern life in one of the driest countries on Earth.
A system that begins in the sea, crosses the desert, and ends as clean water for cities, industries, and millions of people.
It is not just a desalination plant. It is a national-scale water machine.
A chain of concrete, steel, pumps, sensors, power, and precision engineering built to turn seawater into survival.
Follow the channel and turn on notifications. Because on this channel, we don't just look at finished mega projects.
We uncover how they were built, step by step, from the first survey stake in the sand to the moment the entire system comes alive.
Thanks for watching, and I'll see you in the next incredible construction story.
Lower it slowly. Watch the alignment on the far side. Okay, hold it there. A little to the left. Got it.
the vibrator moving, we need more flow in this corner. Move it, move it.